Hey guys, Assalamualaikum. Welcome back to another virtual lecture. In the last video, we learned how to construct confidence interval for small sample sizes and when we don't know what the population standard deviation is. Okay, so you're also introduced to this new distribution, which is the student's t distribution, when we want to construct those confidence intervals. Now in today's video, we're just going to look at this distribution and compare it against the normal distribution or the z-table. Okay, so here we have both the z distribution and the t distribution drawn together, so you can compare how their shapes look like. Okay, now the standard normal or the z distribution is the most common normal distribution with mean 0 and a standard deviation of 1. The t distribution looks very similar, right, to the z distribution in that it is also continuous, it is also centered at 0, and it has a bell-shaped curve as well. However, as you can see, the t distribution is shorter and flatter around the center. Okay, so its standard deviation is proportionally larger compared to the z distribution. Say we are asked to find a 95% confidence interval for the population mean. So that 95% is basically the level of confidence. So we know that 95% level of confidence is translated to plus minus 1.96. Okay, that is the case if we are looking at the z distribution. However, if we are asked to find a 95% confidence interval for mu, but we are using the t table, okay, you can see here, if you notice, the t values are much larger compared to the z values. Okay, the reason is because, as I mentioned before, the t distribution is shorter and flatter around the center as compared to the z table. So now I'm going to show you how to find this value, 2.776. Okay, the question here says that the sample size is 5, and then we are asked to find a 95% confidence interval for the population mean. So what you need to do is you just need to look at the t distribution table. Okay, look at, first of all, you need to calculate the degrees of freedom. Degrees of freedom is simply the sample size minus 1. Okay, our sample size just now was 5, right? So minus 1 becomes 4. Here we look at 95% confidence interval, so all you have to do is just put them together for 95%. So here, this is how we get the t value, 2.776. You can read about the other characteristics of the t distribution in your lecture notes here, or if you don't have it, you can always refer to any statistics books. Okay, they're the same anywhere. Okay, let's take a look at example 3. The American Sugar Producers Association wants to estimate the mean yearly sugar consumption. A sample of 16 people reveals the mean yearly consumption to be 60 pounds with a standard deviation of 20 pounds. A. What is the value of the population mean? What is the best estimate of this value? Okay, so now to answer part A, the question is, do you know what the value of the mu is? Do we know the population mean? The answer is, of course, no, not. Because if we already know what the mu is, why do we even bother calculating confidence interval, right? So the answer is always no. We don't know what the population mean is. However, we do know that the best estimate of the population mean is the sample mean, which is 60. All right, what's mentioned here. So that is basically our answer. The population mean is not known, but the best estimate of the population mean is the sample mean, which is 60. Okay, part B. Why do we need to use the t distribution? What assumptions do you need to make? Very simple. We've already learned, right? In this case, we've got a small sample size, and we don't know what the population standard deviation is, sigma. We don't know what sigma is. That is the two main big reasons why we need to use the t distribution. 1, small sample size. 2, we don't know what the population standard deviation is. Okay, what assumptions do we make? We assume that the population is normally distributed. Okay, C, for a 90% confidence interval, what is the value of t? Okay, now we need to look at the t table. Okay, our sample size is 16 and we're asked to find a 90% confidence interval. So we have 90 here, and we know we need to find the degrees of freedom, right? Which is n minus 1. 16 minus 1 is 15, so 90% here and 15. So this is our t value, 1.753. Okay, so we're asked to find the 90% confidence interval for mu, right? So the formula begins with the point estimate, which is x bar, plus minus the margin of error. Margin of error consists of 2, which is the confidence level. Okay, remember we use the t now because we've got a small sample size and we don't know what the population standard deviation is. and the standard error, which is S over the square root of n. Okay, put everything together. What was our x bar just now? 60 plus minus the t that we found just now was 1.753 times the sample standard deviation, 20, over the square root of n, which is 16. Okay, solve this, guys. You will get between 51.235 and 68.765. Okay, so the last question is, would it be reasonable to conclude that the population mean is 63 pounds? Okay, so what you need to do is you just look at the confidence interval that you've developed. Okay, is 63 pounds within that interval? Is 63 pounds within 51.235 and 68.765? If the answer is yes, then yeah, it is. So yes, it is reasonable to conclude that our population mean is 63 pounds because it is within the interval, the confidence interval.